Not show MAC address table, show version. And here we are able to see base MAC address is this one. Let me copy the base MAC address of this switch. And I am going to paste this MAC address over here. In the same way, I will find base MAC address of this switch. So version. Guys, I am expecting you guys have knowledge, at least knowledge of how switch takes forwarding decision, how switch learn MAC address table, and how switch forward traffic on the basis of MAC address table. As we already discussed, switch maintain MAC address table to forward traffic. Okay,
Yes. Yes.
so this is base MAC address of this switch, switch 3. Now, as I told you that by default, priority on all switches same. Out of these switch, one switch is going to become main switch in a spanning tree protocol. We are discussing a spanning tree protocol. A spanning tree protocol. In last class also I told you a spanning tree protocol is a layer 2 protocol which is used to avoid loop. Layer 2 loop. So
Look.
how switches are going to avoid loop? For that, first of all, switch is going to elect one switch as a root bridge. Out of these three switch, one switch will become root bridge. And root bridge, which switch will become root bridge? Switch which will have lower bridge ID. Lower bridge ID. Now question is, what is bridge ID? So what is bridge ID? Who will explain bridge ID? Bridge ID is combination of two things. Base MAC address, first is priority plus base MAC address. Base MAC address, priority plus base MAC address. Now by default priority is priority on every switches is
Same.
32768. 32768 is the by default priority on every switches. Here also by default priority will be 32768. Here also by default priority will be 32768, and here also by default priority will be 32768. Done. So priority of all switches is same by default. So root bridge election will happen on the basis of base MAC address. I'm saying for loop avoidance in the switching, one switch will become root bridge. Now question is, which switch will become root bridge? So switch which will have lower bridge ID will become root bridge. Now what is bridge ID? So bridge ID is combination of two things, priority plus base MAC address. By default priority on every switch is same, that is 32768. Then root bridge election will happen on the basis of what? Base MAC address, yes or no?
Yes.
Now you tell me which switch will become root bridge in this scenario.
I,
Switch which will have lower base MAC address. So which switch have lower base MAC address?
how do you know like which one is lower base MAC address?
Here you can see 0060. Here you can see 0090. So out of switch 1 and switch 2, switch 1 have lower base MAC address.
Oh, okay. We just only count the first four digit,
No,
right?
we need to find until bits are not same.
Then lower bridge ID should be switch 3.
Yes, switch 3. Switch 3 have lower bridge ID. Because here you can see 0002, right? That means when I am checking first 4 value, I'm able to find that switch 3 have lower base MAC address.
Okay.
If 4 value is same, then I will check fifth value. Fifth value is also same, then I will check seventh value, right? And we will
Yes.
identify which switch have lower base MAC address. So switch 3 will become my root bridge in this scenario. This switch will become root bridge. Root bridge. Okay guys, is it clear to everyone till here? How switch
Yes.
3 will become root bridge? Now there are some port role in a spanning tree protocol. Port role. Always keep in mind all ports of root bridge. All ports of root bridge will be designated port. Designated port. What I am saying, all ports of root bridge will be designated port. Guys, if you are thinking that what is designated port, so designated port is the port which sends superior BPDU. Now question is, what is BPDU? Now question is, what is BPDU? So BPDU is nothing but it is like hello message of OSPF or EIGRP. EIGRP or OSPF or any or other routing protocol exchange hello message to form neighborship. So root bridge will send a BPDU and that BPDU is like hello message. BPDU. BPDU. Bridge Protocol Data Unit. BPDU stands for Bridge Protocol Data Unit. And what I am saying, DP, designated port, in short I am saying DP, to designated port, is the port which transmit best BPDU, or we can say superior BPDU, best BPDU. BPDU. So root bridge will always send best BPDU. Getting my point? So all ports of root bridge switch will be DP. Let's say this switch have two ports. One is connected with switch 1 and one is connected with switch 2. So both port will become DP, designated port. And the port which receives superior BPDU will become RP, that is root port. Guys, here I am going to, let's say, connect the cable like this, and like this. So switch 3 is root bridge, so all ports of this switch will become DP, designated port, because it will send superior BPDU. Okay, and the port which receives superior BPDU will become RP, that is root port. There are three types of port in a spanning tree: DP, designated port; RP, root port; and alternate, that is blocking. So this port will become RP, this port will become RP, and on this single segment now we need to find which port will become DP and which port will become block. So see, here we need to identify switch 2 will also send BPDU or hello message, switch 1 will also send hello message on this segment. Now we need to find that which switch is forwarding best BPDU, best hello message. So when let me make you understand again, here I have one link, here I have one link, here I have one link. This port will become definitely DP. As I told you, all ports of root bridge will become DP, and it will send one BPDU from both DP, from both designated port. In BPDU, it will share root bridge ID. It will share root bridge ID. So root bridge ID will be what? 32768 plus base MAC address. This MAC address, let's say I am going to use only last 2 bits, 55. Here also 3, 2, 7, 6, 8 plus 55 will be the breeze ID. Inside BPDU it will share their breeze ID. After that, switch 2 will relay this BPDU message to switch 1. And in this BPDU there will be two information. One, root breeze ID. Root breeze ID. And after that, sender breeze ID. Sender breeze ID. Guys, when switch 3 will send BPDU, in that BPDU, root bridge ID and sender bridge ID both will be same because switch 3 is the root bridge. Yes or no?
Yes.
But when switch 2 will send BPDU, root bridge ID will be this one and sender bridge ID will be this one. Yes or no? When switch 1 will send, root bridge ID will be this one and sender bridge ID will be this one. So out of these two switch 1 and switch 2, which switch is sending superior BPDU? For that, first of all, it will check root bridge ID. So root bridge ID in both BPDU is same bridge ID of switch 3. After that, it will check what? Sender bridge ID. So out of switch 1 and switch 2, which switch have lower bridge ID?
Switch 1.
Switch 1 have lower bridge ID. That means switch 1 is sending best BPDU, and port which send best BPDU will become DP, and this port don't have any option to become DP or RP. This port will become alternate. And a state of DP and RP is forwarding, and a state of alternate port is blocking. So this port will be automatically blocked by switch. So now loop will not form because now you can see topology is like this: switch 1, switch 2 and switch 3. There is connection like this, not in loop. Getting my point?
Yes.
So this is how we can avoid loop in a spanning tree protocol. Okay, if you want to see, I can show you. I am going to connect the cable between switches. Done, done and done. Just wait for some time. After some time you will see that this port will become blocked and all other ports will be in forwarding state. Are you able to see?
Yes. This happen will do automatically, right?
Yes, automatically. A spanning tree is by default enabled on switch. We don't need to configure it. Just we need to understand only that how it's working.
Got it. Okay.
We don't need to configure it. By default, a spanning tree protocol is enabled, and on any switch, if you want to verify, let's say on switch number 1, I want to verify that which switch is my root bridge. So I will run command show a spanning tree here. Show a spanning tree. Are you able to see the information of root bridge? This is information of root bridge and this is information of bridge ID. Means this is my bridge ID and this is root bridge ID. So here actually this is MAC address of switch 3 and this is MAC address of switch 1. So switch 1 have knowledge that the switch who is using this MAC address is the root bridge. And you can see 0/1 port is RP, 0/1 which is connected to root port is RP, and the port which is connected to switch 2 is DP. And on switch number 2, if you will check a spanning tree protocol, so a spanning tree protocol, you can see 0/2 port is alternate and a state of alternate port is blocking, and rest other port is 0/1 is root port and a state is forwarding. Is it clear?
Yes.
Why we are using it? Just to avoid the loop. See, in this topology, if I will disable the spanning tree protocol, loop will form. In last class, I saw you also that how loop can form in the topology. And if let's say this link will goes down, if my primary link will goes down, then automatically this port will come in forwarding state. If you want to see, I can do one thing. On switch number 2 I can down F0/2 interface F0/2. I am going to say shutdown to this port, shutdown, not 0/2, no, shutdown 0/1, sorry. Interface F0/1 is connected with switch 3, shutdown. I have done this port, so automatically you will see upper link will come up, upper port will come in forwarding state. You can see, yes or no?
Yes.
Again, if this port will come up, no shutdown. This port is no shutdown. You can see this port have gone in blocking state.
Yes.
So actually how a spanning tree protocol is working, first of all switches are going to elect one switch as root bridge. So here in this topology, root switch 3 will become root bridge. Once a switch will become root bridge, their all ports will become DP, designated port, and a state of designated port is in forwarding state. After that, this switch, root bridge switch, will send one BPDU. BPDU is like a hello message. In the BPDU message, it will send two information: root bridge ID and sender bridge ID. Root bridge ID and sender bridge ID both will be same because switch 3 is the root bridge. After that, it will forward to switch 1 and switch 2, and switch 2 will relay to switch 1 and switch 1 will relay to switch 2. But when switch 1 will relay to switch 1, it will share their own bridge ID as a sender bridge ID, and switch 2 will share their own bridge ID as a sender bridge ID. So it will compare that which switch is sending best BPDU. So switch 1 have lower MAC address, so switch 1 is sending best BPDU. So this port will become DP and this port will become alternate. Got it?
Yes. I have a question here.
Yes.
So we can send other data through switch 2 to switch 1, right? On the
Yes.
same.
Now let's say here is one PC.
Yeah.
And here is one PC, and here is one PC. Let's say PC A, PC B, and PC C. PC A want to communicate with PC B, it will communicate via this link. If PC A want to communicate with PC C, it will communicate via this link.
Oh, the whole link is blocked, the other one.
Yes, this port is not for data forwarding until and unless this link will goes down or this link will goes down. If
Okay,
any link, this link or this link will goes down, then this port will come in forwarding state. Actually, my logical topology is like this now. This is my logical topology. There is no any connection between switch 2 and switch 1. Getting
Got
my
it.
point?
Yes. Thank you.
Okay, so guys, I am going to design one topology here in Paint, let's say, just to ask you question, because my concept is clear. Just I am going to ask a question you guys, right? Switch 1, let's say switch 2, switch 3, and switch 4. Let's say, okay, first of all, let me write the name of switch 1, switch 2, and switch 4. Let's say this is 0/1 and this is 0/2. This is 0 slash, let's say, 1, and this is 0/2. This is 0/0. Not 0, 0/1. This is 0/2.
One. Zero slash two.
Okay, let's say MAC address of switch A is 0A. 0A is the MAC address of switch 1. 0B is the MAC address of switch 2. 0C is the MAC address of switch 3, and 0D is the MAC address of switch 4. First of all, tell me which switch will become root bridge.
Switch 4.
Switch 4 or
Zero
switch
A.
1?
No, switch 1.
0A.
Lower.
Switch 1.
Switch 1, this switch is my root bridge.
Yes.
Root bridge. Done. Very good. This switch will become root bridge. That is absolutely fine. Now, this port will become what? Okay, what will be the bridge ID of switch 1? First tell me that. Bridge ID. 32768 plus 0A.
0A.
Okay. This is the bridge ID of switch 1. What will be the bridge ID of switch 2? 32768 plus 0B. What will be the bridge ID of switch 4?
6 plus 0D.
0D. And what will be the bridge ID of switch 3? 8 plus 0C. Am I right?
Yes.
So switch 1 have lower bridge ID, that's why switch 1 will become root bridge. On switch 1 will become root bridge, all ports of switch 1 will become what? DP, because it will send superior BPDU, best BPDU. In this BPDU which switch 1 will send, root bridge ID and sender bridge ID will be same. After that, it will forward the BPDU message to switch 2, as well as it will forward the PPDU message to switch 3. So these two ports which will receive superior BPDU will become what? RP. So this port will become RP. And this port is also receiving superior BPDU, so this port will become RP. Fine. Till here, is it okay? What I am saying, DP is the port which sends superior BPDU, which transmits superior BPDU, and root port is the port which receives superior BPDU. Okay. When switch 1 will send BPDU message, in that BPDU message bridge ID will be 32768 plus 0A, and sender bridge ID will be also 32768 plus 0A. Root bridge ID and sender bridge ID both will be same. Okay, when switch 2 will receive BPDU from router from switch number 1, it is going to relay that to switch number 4. Yes or no?
Yes.
And switch 3 is also receiving one BPDU, so switch 3 will also relay that BPDU to switch 4. So switch 4 is receiving BPDU on 2 interface. Yes or no?
Yes.
Yes or no?
Yes.
Okay. First of all, this port. This port will become what again? DP, because this port is transmitting BPDU and this port is receiving BPDU. So this port will become RP because it is receiving BPDU. After, okay, let me discuss note like this. Okay, switch 4 is receiving BPDU on 2 port, on 0/2 and on 0/1. Now switch 4 need to identify I am receiving superior BPDU on which port. Can anyone tell me switch 4 is receiving superior BPDU on which port? See guys, when switch 2 is transmitting the BPDU, root bridge ID is 32768 plus 0A and sender bridge ID is 32768 plus 0B. When switch 3 is sending the BPDU to switch 4, root bridge ID will be again same 32768 plus 0A and sender bridge ID will be 32768 plus 0C. Now can you identify which switch is sending superior BPDU?
Yes. So switch 2 will send superior BPDU.
Exactly. Switch 2 is sending superior BPDU because in the BPDU sender bridge ID is lower.
Yeah.
Root bridge ID is same in both BPDU, then it is going to check sender bridge ID. So sender bridge ID is lower in BPDU of switch 2. So that means switch 4 is receiving best BPDU on 0/2 port. So 0/2 port is going to become what? RP. Okay.
Yes.
And after that, switch 4 will relay this BPDU to switch 3 also. Am I right? Switch 3 will relay the BPDU which switch 4 is receiving from switch 2. In
Yes.
this BPDU, sender root bridge ID will be again 32768 plus 0A, and sender bridge ID will be 32768 plus 0D. Now tell me, on this particular segment, which switch is sending superior BPDU?
Switch 3.
Switch 3, exactly, very good. So this port will become DP and this port will become what? Alternate. And as you know, alternate port state will be blocking. So my logical topology is switch 1, switch 2, switch 3, switch 4. There is one connection between switch 1 and switch 2. There is one connection between switch 1 to switch 3. There is one connection between switch 2 to switch 4. There is no any connection between switch 3 and switch 4. So can loop form in this topology? No. Is it clear to everyone now?
Yes, it's clear.
Yes.
So this is a spanning tree protocol, and by default a spanning tree protocol is enabled. As you see, I have not configured anything on switches, but a spanning tree protocol is running by default. So just you need have some information about a spanning tree protocol. Someone can ask you what is a spanning tree protocol and why we are using it. By default it is enabled or disabled, and how root bridge election will happen in a spanning tree protocol, how root port election can happen, what is designated port, what is RP means root port, what is alternate port, what will be the state of DP, state of RP, state of alternate port. These are the questions that anyone can ask you. Okay. So a spanning tree protocol is a layer 2 protocol which is used to avoid loop. It have 3 port role: DP, RP and alternate. First of all, to avoid loops, switches are going to elect one switch as a root bridge. So which switch will become root bridge? Switch which will have lower bridge ID, that switch will become root bridge. All ports of root bridge will become DP, designated port, and a state of designated port will be forwarding. DP means the port which will transmit the superior BPDU, and RP means root port is the port which will receive the superior BPDU. Okay, so now you have election knowledge about the ports, how as spanning tree protocols are going to block the backup link. Actually, a spanning tree protocols block backup link. First it will find which link is the backup link, and after that it will block that link. Done. Now in this scenario, let's say I don't want to make switch 3 as a root bridge. I want switch 1 should be my root bridge. Getting my point? What
Yes.
I want? Switch 1 should be my root bridge. So we cannot change MAC address, yes or no? But we can change the priority value. Here I can set priority value what? Less than 32768. Let's say here I have set priority value what? 0. So now this switch will become root bridge, not this switch. Because MAC address will compare if priority will tie. So see how I can change it. On switch number 1, by default, if you will run command show a spanning tree, you can see this switch is not root bridge. Right, this switch is not bridge. This is information of root bridge, and this is information of bridge ID, means they are on bridge ID. And on switch number 3, if you will run this command show a spanning tree, you can see it's saying this bridge is the root. Yes or no?
Yes.
So with the help of priority, I can manipulate root bridge as well. Let's say switch 1 have good hardware. So I want that switch 1 should be my root bridge. So here I can set priority. How? See. In global config mode, you will run command a spanning tree. After that, VLAN. For which VLAN? We will understand VLAN. For VLAN 1, let's say. And then I'm going to say priority. Okay guys. So if I will set priority what 0 over here, or I can set priority in this range 4096. Let's say I have set this priority, and now if I will check show a spanning tree, so you can see it's saying this route is breeze. Yes or no? Because here priority is not 32768. Priority is 4097. Okay, and on switch 3, now if you will run command, earlier it was saying this switch is root bridge, and now if you will run again this command show spanning tree protocol, so it's saying root bridge is the bridge whose priority is this one and MAC address is this one. I am not the longer root bridge. Fine. Is it
Yes.
clear?
Yes.
And if switch 1 is root bridge, then you can see this port is blocked, not this port. So again it will depends, because now switch 1 is my root bridge, so these two port will become DP, this port will become RP, this port will become RP. On this particular segment, switch 1 and switch 3 both are sending BPDU. Now question is which are sending superior BPDU. So switch 3 have lower MAC address, so it is sending superior BPDU. So this port will become what DP, and this port will become alternate. Is it clear?
Yes.
Now we are going to start next topic, that is VLAN. Can I move?
Yeah.
Is it okay? Any doubt, any confusion? Yes. Okay, so I have configured IP address on all computer. This computer have IP 10.0.0.1 and this computer have IP 10.0.0.6. From this PC I am going to ping, let's say any PC, ping and 10.0.0.2. I'm able to ping, yes or no? If I am going to ping 3, I'm able to ping, means all PC can ping to each other. I'm going to ping 4 also. See, I'm able to ping. I'm going to ping 5, then also it will work 45. Oh, sorry. 5 also, that means these computer can communicate with each other. Yes or no? You know why these machines are able to communicate with each other? Because on this switch, all ports of this switch by default belongs to single VLAN. If you will check MAC address table of this switch, MAC address table, that switch used to forward the traffic. So we already discussed how switch build MAC address table. So MAC address table, in this MAC address table you can see it have learned MAC address of computer on this port, on 0/2 port, 0/1 port, 0/3 port, 0/2 port, and all ports are member of same VLAN, VLAN 1. This is the first way. Second way is show VLAN brief. I can run command show VLAN brief, and you can see these all ports of switch belongs to which VLAN? VLAN 1. There is some more VLAN like VLAN 1002, 1003, 4, 5, but there is no any port in this VLAN. By default, all ports belongs to VLAN 1. That is the reason why these machines are able to communicate with each other. Two different VLAN user cannot communicate with each other, guys. Okay. Two different VLAN cannot communicate with each other. So let's say here, as I told you, that this is my different department. Let's say this is my sales department. Sales department, and this department is, let's say, any other department, a content department. This is my, let's say, a content department. And what I want that sales department user should not be able to communicate with a content department. Getting my point? I want that sales department should not be able to communicate with a content department. So what I can do, I can put these all interfaces in different VLAN. and these all interfaces in different VLAN. Two different VLAN cannot communicate with each other. So what is VLAN, guys? VLAN is used to break broadcast domain. VLAN is used to break broadcast domain. Let me show you practically. On this switch, simply see, I want
Excuse
to,
me, sir.
yes,
I said like VLAN is connect multiple device and network nodes from different lanes. You say like it's breaking, but the definition
VLAN
of VLAN
VLAN is
connection.
used to break the broadcast domain. By default, these all ports are in single broadcast domain.
It doesn't connect like multiple device and networks.
One VLAN means one broadcast domain. Two VLAN means two broadcast domain. Getting my point? By default, these all ports are in VLAN 1. That means these all ports are in single broadcast domain. And that is the reason why these users are able to communicate with each other. Okay.
Okay, clear.
Now I want to stop communication between these user to these user. Means sales department users should be able to communicate with each other, and a content department user should be able to communicate with each other. But sales department user cannot communicate with a content department user. This is real time scenario. In my company, maybe there are multiple department. Yes or no? So what I will do, simply I can create two number of VLAN on this switch. Simply I can create two number of VLAN on this switch. This is my switch. In this switch I am going to create two number of VLAN. Let's say VLAN 10. This is command to create VLAN. Once I have run this command, and now if you will check do so VLAN brief, you can see one VLAN is added there, VLAN 10. Yes or no? But there is no any port in VLAN 10 now. There is no any port in VLAN 10 now. And we can configure name as well. Let's say VLAN 10 and then name is sales. And do so VLAN brief. Now you can see VLAN 10 is created whose name is 10, but there is no any interface in VLAN 10. In the same way, I will create one more VLAN, VLAN 20, and I am going to give name to this VLAN as a content. Okay, and now if you will verify VLAN, do so VLAN brief. You can see there is two extra VLAN, VLAN 10 and 20. Name is also there. Now I want to put interface 0/1, 0/2 and 0/3 in VLAN 10 and 0/4, 5, 6 in VLAN 20. Right? So command will be, first you have to go to interface F0/1 and you will run command switch port access VLAN 10. This command will put this interface in VLAN 10. Done. After that, interface F0/2 switch port access VLAN 10 exit and switch port access interface F0/3 switch port access VLAN 10. Done. And do so VLAN brief. Now you can see in VLAN 10 there are some interfaces 0/1 to 0/3. Done. Is it okay?
Yes.
Okay. I am going to put 4, 5, 6 in VLAN 20. So interface F0/4 switch port access VLAN 20.
Sir, can you do all interface in the single line or no?
Yeah, on real devices we can use range command, but here in packet tracer it's not support.
Okay, because
range command.
if it's like 100 computer, we cannot do like one by
No,
one.
on real devices you can do like that. Interface range. See, interface range F0/4 to F0/6 like this. Switch port access VLAN 20. I can use this command, na? I will use this command. Getting my point, brother? Now these all ports will put in VLAN 20. So VLAN brief. See. Here also I can use range command, no problem. Any dot?
No.
And
Yes.
now if you will check the VLAN, see, from here I can ping 10.0.0.2 because this user is in same VLAN. I can ping 3 also because this user is also in same VLAN. But I cannot ping 10.4. See, ping will not work. So two different VLAN user cannot communicate with each other. Okay.
Yes.
On any switch, I'm going to run one command. See, by default, there are multiple protocol enabled on switches. So, VTP status. We are able to see some output in VTP status. That means VTP protocol is by default enabled on switch. Now question is, what is VTP? So guys, VTP is used to propagate VLAN information. Like if I have multiple switches, switch 1, switch 2, switch 3, and let's say switch 4, switch 5. And I need to create, let's say, 100 VLAN. So if I need to create 100 VLAN, then on all switches I need to create 100 VLAN, yes or no? Let's say if in my network there are 100 switches, then it is very lengthy task to configure 100 VLAN on all switches. Yes or no? We have discussed till now VLAN concept. I can use range command, interface range F0/1 to 1 to F0/10. I can put multiple interface in a single VLAN at a time. I can create multiple VLAN at the same time, VLAN 10 to VLAN 20, like this, not like this, VLAN 20. Here we don't have option, I think, but on real devices you can configure multiple VLAN at the same time as well. But configuring 100 number of VLAN on 100 number of switch is lengthy task. Yes or no? So that's why we have a protocol called VTP. VTP. VTP stands for VLAN Trunking Protocol. It is used to propagate VLAN information. Just you need to create VLAN on one switch, and automatically that switch will propagate the VLAN on all other switches with the help of this protocol, that is VTP. And by default this protocol is enabled. You don't need to enable it, but there is some requirement. So before understanding VTP, you have to understand trunking. Trunking. So first we will discuss trunking protocol. So here I'm going to use two switch 1, switch 2. Let's say here I have some user this user is in VLAN 10, this user is in VLAN 20, and this user is in VLAN 30. Here I have one user in VLAN 10, 20, and 30. Guys, how many link I need to connect between switch 1 and switch 2?
One link.
How one link can carry traffic of all VLAN? This is in VLAN 10, VLAN 20, and VLAN 30. This is in VLAN 10, VLAN 20, and this is in VLAN 30. If you will, let's say I have connect one link and I have put this link in VLAN 10, here also and here also. Now VLAN 10 user can communicate with VLAN 10 user, but VLAN 20 user cannot communicate with VLAN 20 user. For that I have to use one more link between switch 1 and switch 2, and this link should be in VLAN 20. In the same way I have to use one more link for VLAN 30. Yes or no? Because single link cannot carry by default traffic of multiple VLAN. This link, upper link, will carry traffic of VLAN 10, middle link will carry traffic of VLAN 20, and lower link will carry traffic of VLAN 30. Am I right? Guys, it will be better if I will, start trunking tomorrow. So what I will do, I will start trunking protocol tomorrow. Okay, because first I have to make you understand some basic about VLAN, that how packet flow occurs in case of VLAN. After that I will make you understand VLAN. Okay, so in switching module it will not take much time, don't worry. After trunking we have VTP protocol, we have DTP protocol, we have ether channel, we have some access control list, we have NAT/PAT. okay, these topics are left, so we will cover around, it will take 10 days, 10 more days, 10 to 12 more days. So anyone have problem if I will start trunking tomorrow?